Welcome. Would like to continue with answering our questions from the 2018 science paper 2, that is chemistry, that was written on the 7th of August, and we are continuing with question number 5. So just a reminder, like we always do, please remember to subscribe to support this YouTube channel. When you subscribe, the next time we post a tutorial video or a video on any of the lessons that we discuss, you're going to be receiving a notification. So please remember to subscribe and share with friends and those that might benefit from this. So we'll start with question number 5. So question 5 reads, define an endothermic reaction. So how do we define an endothermic reaction? So we define an endothermic reaction as a chemical reaction in which heat energy from the surroundings is absorbed by the reactants in order for them to produce products. So this is a chemical reaction that involves the taking in of heat from the surrounding. The heat that is taken in form of heat energy from the surrounding acts as an activation energy to help the reaction start. So we can simply indicate here that a reaction that takes in heat from the surroundings. We go to question number 5b. Study the reaction below, and we can see it there. That is the reaction of iron metal reacting with sulfur in the presence of heat to produce iron sulfide. Now the question is, explain why the above reaction qualifies to be an endothermic reaction. So like we mentioned above there, an endothermic reaction is one that takes in heat from the surroundings by the reactants to form products. So as we can see here, iron is reacting with sulfur. Now for this chemical reaction to take place, heat must be available. So this chemical reaction is taking place in the presence of heat to produce iron sulfide. So because heat is required, this type of a chemical reaction qualifies to be an endothermic reaction. So it qualifies to be an endothermic reaction because heat is available and used by reactants. So it qualifies to be an endothermic reaction because it is taking place in the presence of heat to form iron sulfide, and therefore it qualifies to be an endothermic reaction. We go to question C. State one natural process that takes place in plants that is classified as an endothermic reaction. So we know there are so many processes that take place in plants, and the prominent ones, the most easiest ones to remember are photosynthesis, which takes place during the day, and respiration, which takes place during the night. Now, photosynthesis occurs in the presence of sunlight. So this type of a chemical reaction requires light energy from the sun to take place. So because it requires this type of energy from the sun for it to occur, photosynthesis is qualified or classified as an endothermic reaction because it takes place in the presence of light. We go to C. 2. write the chemical equation for your answer in C1 above. So we are talking about photosynthesis, which is classified as an endothermic reaction. What is the chemical equation for such a reaction? So we know that photosynthesis is the production of food by plants using carbon dioxide and water. So the reactants involved are carbon dioxide reacting with water, as you can see there. Now all this is taking place in the presence of light from the sun, and this light is trapped by chlorophyll. Now what are the products of photosynthesis? Glucose and oxygen are the products of photosynthesis. Therefore, the chemical equation can be read as carbon dioxide reacting with water in the presence of light, which is trapped by chlorophyll in plant leaves, produces glucose and oxygen gas. So we are done with question number 5 in this question paper. So now we can move on to question number 6. Question number 6 reads as follows. The graph below shows how the mass of a lump of marble chips, that is calcium carbonate, immersed in dilute hydrochloric acid varied with time. So as we can see from there, we can see the amount of marble chips that was being reacted and how it was reducing as time was going. So we want to find out how time and the amount of mass was related as the chemical reaction was proceeding. So let's go straight to the first question under this under question 6. The A part says, how long after the start was the reaction complete? So we are talking about how long, so meaning we are dealing with time. So from 0 time up to 5 minutes. Remember, time is in minutes. Now we are taught to say how long after the start was the reaction complete. So we are talking about when did the chemical reaction came to a complete. How do we identify from the graph that the chemical reaction is now come to a completion? So one prominent thing or feature that can help us know when the chemical reaction came to a stop is simply by looking at where did the graph became flat. Remember, the mass was 2.5 and it kept on reducing, and somewhere here the graph became horizontal or constant. So at this particular time we are going to understand that the chemical reaction came to a stop because the mass of the reactant stopped reducing, it remained the same. So this simply means that the chemical reaction came to a stop here. Now, how long did this take? Remember, from here, if we come down, the number that is there in the corner is 0. And then when we come to the point where the graph came to a stop, we are going to understand that it came to a stop directly above 2. Therefore, we can say it was after 2 minutes that this chemical reaction came to a stop. The B part of question 6 says, write a word equation for the reaction which takes place. Remember, from above there we are told to say the graph below shows the mass of lump of marble chips immersed in dilute hydrochloric acid. So we have marble chips reacting with dilute hydrochloric acid. So now, what was formed when these reacted? So the word equation is as follows. Remember, we are taught to say we have to indicate the word equation. So the word equation is, we have calcium carbonate reacting with hydrochloric acid to form. So what is formed when calcium carbonate reacts with hydrochloric acid? So one of the products is calcium chloride, and the other products of this is a gas whose name is carbon dioxide. So this is the word equation for the reaction that is taking place between calcium carbonate and hydrochloric acid. Apart from calcium carbonate and hydrochloric acid, we also understand that water is also one of the reactants. So I mean the products. So when calcium carbonate reacts with hydrochloric acid, it forms calcium chloride, a gas carbon dioxide, and water. We got the last part of questions, the third part, which is the C part of question 6 says, using the graph shown above, determine the amount of marble chips in excess. So we go to the graph. The initial amount of marble chips was 2.5 grams. And these marble chips, the mass started reducing as time was passing. Then after 2 minutes, the mass of the marble chips remained constant, showing that the mass, there was some little amount of marble chips that were left out. And these are the ones we want to find out which ones are in excess, meaning the ones that remained after the chemical reaction had taken place. So we'll go back to the graph. This is the mass that was reducing. And then at this point, the chemical reaction stopped after 2 minutes. But now, how much mass was available at this particular time? So we follow this graph, we go straight there, we find that the total amount of mass that was left was 0.5 grams. So this means that the amount that was in excess was 0.5 grams. This was the amount that was in excess. Let's go to the D part. It says, calculate the volume of gas measured at room temperature and pressure produced. We are talking about the gas which is carbon dioxide, which was produced. So now, how much was this in terms of volume? So for us to determine the volume of the carbon dioxide, first of all, we might want to determine the number of moles of carbon dioxide, of calcium carbonate that remained. So how do we determine the calcium carbonate that remained in terms of mass and in terms of moles? So we are going to say, for calcium carbonate, the number of moles that remained were mass over the relative molecular mass. We know that the mass, the excess, was 0.5 grams. So 0.5 grams. Then the relative molecular mass of this one is 100 gram per mole. That is the relative molecular mass. So it is 0.5 divided by 100. So this gives us 0.02 moles. So in terms of the number of moles for calcium carbonate, these are the number of moles that remained. But remember, we want to find the volume of the gas, which is carbon dioxide. So how do we relate this to the volume of the gas? We are going to bring back our equation, which we wrote as a word equation. Remember, this is our equation. So let's write now in terms of a chemical equation. So our chemical equation is going to be calcium carbonate reacting with hydrochloric acid forms calcium chloride and carbon dioxide and water. So this is our chemical equation, and we need to balance it. So here we have 1 atom of calcium. We have 1 atom of calcium on the product side. It's balanced for now. 1 atom of carbon, 1 atom of carbon. 3 atoms of oxygen, we have 2 plus 1, 3 atoms of oxygen. Then we have 1 atom of hydrogen, there we have 2, so we need to balance it by putting a 2 there. Then we have 2 atoms of chlorine, also there we have 2 atoms of chlorine. So this reaction is balancing. Now our focus, our main issue is finding the volume of the gas, which is carbon dioxide. We have found the number of moles for calcium carbonate to be 0.02. So our concentration is on the mole ratios between calcium carbonate and the carbon dioxide. So in which ratios are they reacting according to this chemical equation? So 1 mole of calcium carbonate is producing 1 mole of carbon dioxide. So if 1 mole is producing 1 mole of calcium carbonate is producing 1 mole of carbon dioxide, it simply means that these are reacting in a 1-to-1 mole ratio. So since we found calcium carbonate as 0.02, it simply means that these are the number of moles that are being produced even for carbon dioxide, because they are reacting in the ratio 1-to-1. So now we have found that the number of moles therefore for carbon dioxide is 0.02. Now we can get our periodic table. On the periodic table, we are taught to say the volume of 1 mole of any gas is 24 cubic decimeters at room temperature and pressure. The question is asking us to calculate the volume of the gas produced at room temperature and pressure. So we'll make reference to the same value. So if 1 mole of any gas can produce this volume of any gas at RTP, what about 0.02 moles of this? How much volume can it produce? So you realize that if you multiply 24 multiplied by 0.02, this number multiplied by that number, it is going to give you 0.48. Therefore, the volume of carbon dioxide produced is 0.48 cubic decimeters. So just to go through this, for us to determine the volume of the gas produced, we need to write a balanced chemical equation and then try to determine in which mole ratios are the two, the calcium carbonate and the gas being produced reacting. So we realize that they are reacting in the 1-to-1 mole ratio. Now we found the number of moles for calcium carbonate, and we discovered the number of moles as 0.2. So I beg your pardon, I should have written a 2 here, not 5. It's 2 divided by 100. So for us to determine the number of moles for calcium carbonate, we divided the mass that was used, the amount of mass that was used, from 2.5 to 0.5, and the amount of mass is 2 divided by 100. It is giving us those number of moles. So since the number of moles that were used up for calcium carbonate to produce carbon dioxide were 0.02, then since these two are reacting in the 1-to-1 mole ratio, so it means that the same number of moles also applies for carbon dioxide which was produced. Now, according to these values, 1 mole of any gas at room temperature and pressure produces 24 cubic decimeters. So if 1 mole can produce that amount, what about 0.02 moles? And then we cross multiply, it gives us 48. So the volume of the gas produced, at RTP was 0.48 cubic decimeters. We can now move on to question number 7. Question number 7 reads as follows. Below is a diagram showing part of a periodic table. The letters used are not the true chemical symbols. I'm sure we are able to observe that one there. So we have A, B, C, D, E, and F. So the A part of the question says, using the letters only, choose the element which has the highest density. We all know that elements between group 2 and group 3, these that are called transitional elements, most of these elements have got the highest densities. And this makes us qualify C to be an element which has got the highest density. In fact, when you look at the periodic table, these elements from this column to that column there, these elements are all classified as transitional elements. And most of these elements, especially these that are in period 6, most of these elements have got the highest densities than any other elements on the periodic table. So this simply convinces us to say, since the question says using letters, so letter C is one of the elements with the highest density. Choose the element which 2 is used in high light intensity bulbs. Most of the elements that are used in bulbs are those that are non-reactive elements. And we understand that elements in group 8 or group 0 or noble gases, these elements are not reactive at all. And these are the elements that are mostly used in bulbs. So element F qualifies to be one of the elements that are used in high light intensity bulbs. We go to the third part, the 3 part, Roman numeral number 3. Which element forms an ion with a positive 2 charge in its halides? We understand that the trends of the periodic table. Most of the elements that are found on the left are the ones that lose electrons to those that are found on the right. These elements usually form positive ions. Now, which element between A and B qualifies to be one which will have a positive 2 charge? Remember that these elements are grouped in these periodic table, in these groups on the periodic table according to the number of electrons in their outer shells. So elements in group 1 have only one electron in the outermost shell. Elements in group 2 have 2 electrons in the outermost shell, and so on and so forth. Now, look at the 2. Group 1, it simply means that this one has one element, one electron, and when it loses, it will simply have a positive charge, one positive charge. This one is in group 2. When it loses 2 electrons, it is going to have a positive 2 charge. Therefore, an element which forms an ion with positive 2 charge in its halides, meaning this element reacting with any of these elements in group 7, it forms a positive 2 charge. Therefore, A qualifies to be that element which will form an ion with a positive 2 charge. We got to the B part. Using the letter D, which is this one, write a balanced chemical equation for the reaction of element D with oxygen. So we are talking about element D. Element D is reacting with oxygen to produce this oxide. Now we go to element D. Element D is in group 1, 2, 3. So element D has a valence of 3. So since element D has a valence of 3, and we know that oxygen has a valence of 2, therefore when writing the chemical formula for the compound formed between D and oxygen, D is going to swap valences with oxygen. We already said element D is in group 1, 2, 3, so it has a valence of 3. So the valence for D will go to oxygen. Meanwhile, we know that oxygen on the periodic table is in group 6, so it has a valence of 2. 6 plus 2 makes 8, so it is in group 6 and has a valence of 2. And the valence for D will go for oxygen, will go to D, and the chemical formula is going to look like that for the compound formed between D and oxygen. Now, since the question has said write a balanced chemical equation, so we simply have to balance this. We know that we have how many elements for D, how many atoms of D? 1 here. There we have 2. Oxygen we have 2 there, then there we have 3. So for us to balance this one properly, since 2 and 3 are not in the same number and the same category of numbers, this is an odd number and this is an even number. So to balance up this, we shall put a 3 here, so that we have 3 times 2 for oxygen, we are going to have 6. So we'll put a number which we can multiply with 3 to make 6. So we'll put a 2. So 2 multiplied by 3 gives us 6. And for element D, this is 2 times 2 gives us 4. Therefore, to balance up this chemical equation, we shall put 4 there. And the equation will look like this. So 4D reacting with 3 moles of oxygen gas to produce 2D2 and O3, like that. So this is a balanced chemical equation for the reaction between element D and element of oxygen gas. So for today we are going to end here. We are going to continue with this paper, and next time we are going to have a lesson. We're going to answer questions number 8, questions number 9, and we'll also go to section C, where we'll answer questions 1, 2, and so on and so forth. So thank you for your time, for taking time to listen to this video, and we hope that wherever you do not understand, please drop your comments in below the video here, any questions that you might have on this, and we'll be able to attend to them and answer them together with you. Remember, do not forget to subscribe to this channel. Thank you so much for taking time to listen to this lesson.